record this session. I just started recording this session. We're working through exercise 2.2, and we're just sorting our test scores here. We're setting decreasing, I think we set to true. So let's type that in here. Okay, so it sorts from highest to lowest. And if we could sort again, decreasing equals false. All right, somebody pasted in a lot of code. All right, thank you. We'll go back to our questions. I just wanted to talk a little bit about sorting real quick. Sorting a vector. This does not change the order that is in the test scores vector, right? You see that when I sort it, I didn't save the output of that sort. If I did, and I updated test scores, that would be perfectly appropriate. Okay, but we're not doing that right now. Clear my console window. Let's go ahead and move on to the next task. Create a data frame called grades comprised of two vectors, test scores and students. So how would what's a data frame first off? Well, here we could say data frame. I don't know if this will give us anything. So it's not. So, but there is something called data dot frame. So we can look at that. That's a function. And data dot frame is a function that creates data frames. Well, that looks like something we want to do. And so a data frame allows us to have data that's organized in columns and rows. So think of your Excel spreadsheet again. When you had your Excel spreadsheet, it had one vector in it, and it was called students. And then you had another Excel spreadsheet. Let's think and it had the vector called test scores. And now we want to combine both of those into a spreadsheet. So we have 2 columns and 7 rows, right? And we can have n columns. We can have as many columns as we need to create and how data frames are organized, which is very important, is in what we call a tidy way. So this is a kind of a word that we're going to use, tidy. And that means that every variable is stored as a column. I'm going to just write that out. Also, every observation is stored as a row. Very important concept. So we want always our variables to be stored in columns and our observations to be stored in rows. So now how would we create our data frame called grades comprised of the 2 vectors? Anybody want to share what they've done? Borja, perfect, right? And I like that you put in students first, as that being the first column and test scores being the second column. That makes more sense, right? Great. So why don't we go ahead and do that? So we start by naming our data frame. We'll call it grades. And then we're going to use the data.frame function. And we're going to pass in, I think we said students first, right? And test scores. Good. How could you transpose it? You could just recreate it. We'll talk about reordering of columns at a different point, but you could just simply do this, just reassign it like that. Oops, like that, for instance. Okay, I'm not going to do that. And you just mean how can I transpose the columns or put them in a different order? Transposition has a different meaning also when we talk about data. And we use a function called reshape to reshape our data from, say, wide to long format. Okay, so great. We've created a data frame. What data type is grades? It's a question for you. What data type is grades? It's a data frame. A data frame. It's weird because before when I was just looking at students, that vector, not the column, and I did this, that returned character. But now when I use the class function, I pass in my data structure called a data frame that has both those vectors included as new columns. It's data.frame. Okay. How would I figure out what data type test scores is in my new data frame? Well, we know it's numeric, Jose, but how would I prove it to me? So Mehdi, if I do class test scores, that's gonna tell me the data type of the vector, not the column that I created. So I have a data frame. The data frame has two columns in it. One is called students, the other one is called test scores. How would I know what the data type is of the column named test scores? Oh, so Borja, I like that approach. I could use the str and I could say grades, right? And that gives me some information about all the variables in my data set and the data type. You could figure out what the str function actually means. Oops, by saying str, and it tells you the structure of the object, okay? Another way is to use the class function and reference the data frame and the column, and we reference the column by saying $ test scores, numeric. I do the same thing for students. What's returned? A factor. But when I have my vector, just my students vector, right? Before I combine it into data frame, and I can take the class of that, it was a character. How come it got converted to a factor when I combined it? This is what happens with data frames. It converts without specification. You don't specify it will convert what's called strings to factors by default. Now we can just change that and make sure that students in our grade $ students, this column is going to be a character data type by using a function called as.character, passing in what we're recasting, grades $ students. Reassign it to itself. I have to use the str function, passing grades. Now I have students as a character and test scores as a numeric still. Make sense? Questions on this? All right, so we got our data frame. Let me show you something else. Go to the environment tab, and if I double click or click once on this thing that looks like an Excel spreadsheet, click on that, you can actually go see your list of test scores and students. I'm looking at this information, which is our data frame. These values stored here are not relevant. They are separate. You change something here, it won't be reflected here. You change something here, in any of these vectors, it won't be reflected here. This is an independent data structure, no relationship. What is the reason we changed to character? I'm showing you first that you can, and I'm also showing you when you, by default, use the data.frame function, that it converts all characters to factor variables. And so in lesson 2, you probably read about factor variables, and there's reasons why we use those. In this case, there's not going to be a reason why we use factor variables. Name is not a categorical variable. We're not going to be grouping anything by name in here. Samar asked, does character have an advantage over factor for other calculations? I can't really think of a reason right now. Usually a lot of functions work on factors if they can, as well as characters. So I don't see any, but there's probably some exclusive ones that don't work on characters but also work on factors, right? So we just want our data in the right type, and there's no reason for it to be a factor variable, and we're going to remove that. Now, when we use the data.frame function, which I'm just going to show this in the documentation, let me show you something. We have a parameter that we can say whether we want strings as factors, okay, yes or no, if we want to use that default, okay, so, and what we don't want to, okay, so do not convert to a factor. This documentation isn't very good on that, but it's one of the complexities of data frames, and when we'll talk soon about why we're going to use another data structure called a tibble, which is a simple data frame which does not coerce your data or change it from a character to a factor. Okay. How did I get the table to appear in the upper left-hand window? Great. So you click here. So I'm in the environment tab, and I can only do this with data frames or tibbles. I double click, and then it appears here. Natalia, I hope that's helpful. You could also use the view function and pass in the name of your data frame. How many vectors can be maxed in a data frame? Oh, you can add as many as you want. And there's probably some limit, just like there's limits to most things, but it's just like columns in Excel. Okay. So the limits probably has something to do with your memory and your computing environment. Okay. So we are going to move on to the next part of this. We have our data frame. Okay, it turns out that your professor made a mistake on Monica's test and had to regrade it, and she should be awarded extra 5 points. So let's look at what we see here. Monica, and her grade is 75. We want to update her grade to a 80. We want to award her an extra 5 points. How would we make the correction in the data frame? Well, let's think about how we work with data frames. Our data frame is called grades, right? That's our data frame. If we want to reference the first row and all columns, which is only 2 columns, we say 1 comma using these square brackets. If I want to reference the first row and the first column, I do 1 comma 1. If I want to reference all rows and the first column, I do space, comma, 1. Okay, so if I want to get to a certain position like Monica, what would I type in here in the square brackets? Yeah, Borgia, very good. 2, 2. It's Monica's grade. That's what we want to update in our data frame. So Uli, you're running a conditional statement that says, does it equal Monica? And then what? Is that updating the grade? Not yet. Right. Working on that part. So we'll take a more literal approach. And we'll reference the position. So we'll say something like grades, $ test scores, because we want to update that column, assign that to not just test scores, but the second position in that column. Grades, just write the same thing out, $ test scores, 2, and I like to kind of not hard code the value 80. I'd rather just add 5 to it, right? I don't want to make a mistake with the math, okay? I can go here. This is the solution. I can go back to my screen here. I don't see it updated yet, so I have to go to environment and just like press the grid again. You'll see Monica's score is updated. Okay? Make sense? Wonderful. Problem 3. We want to extract the students who got above or equal to 90%. And so we can see here that, Jerry, James, and Tony, which function saves the 80 value? I'll get to, okay, so let me pause and answer Eric's question. So this is the position that I want to update. So it's almost like I'm updating a variable, right? This data frame, column, position in the column. That's how we read that, okay? And then that same statement, and just add 5 to it and reassign it to this position. It's like a location. Think like latitude and longitude, kind of, right? It's like the location within the data frame, and what I want to update it. Does that answer the question? Great. So we're extracting the students who got above or equal 90%. Here's our list of students, just as a preview. We know that Jerry, James, and Tony did, but imagine if we had 1 million rows, we wouldn't be able to just eyeball it. So we're going to write a little statement that does that and just extract what we call like a subset. And so we use the brackets again, but we'll just use this in kind of a unique way. But I'll wait for you to kind of share your solution with me. Actually 90, okay. All right, these look good. I mean, I'm just gonna use the square brackets to solve this. So grades, $, because I just want to extract the students, right? Those students, a list of students. And that's like, what the problem is saying, extract the students who got above or equal to 90. So I don't want to show the scores. I just want to get the students. So grade students. And then my index, what I want to return is going to be grades, $ test scores. And we know it's going to be greater than or equal to 90. I can press enter here, and I'm getting Jerry, James, and Tony as expected. And so all this is doing here, right, this is like basically having a conditional statement that provides you with the subset or the result set of this conditional statement. Show me all those that are true, greater than or equal to 90 in the test scores columns, and return the students. Okay, any questions on that? levels shouldn't be returned unless, Natalia, you didn't convert the students' grades, $ students to a character. Do you remember when we did that earlier? Yes, and that's why you're getting levels returned, because it's still probably, you probably didn't convert it to a character, which is fine that levels are returned. Uli, in terms of what you're talking about, is there a performance different? And we're working with very small data. When we do some more data wrangling, we're going to be using some other packages that are meant for working with larger amounts of data. But want you to get the kind of fundamentals right off the bat. So we're not going to worry about, performance quite yet. Let's go to problem 4. I want you to sort all students by their test score in descending order. And I want you to do this with the data frame. Don't sort the vectors. I want you to sort the students column in the data frame. Anybody have an answer to that? Okay, so if you've gone through lesson 2, you probably saw some approaches to that. And there's a function called the order function. I'll just say order, and you can learn more about it here. So that's a little hint. So we're going to use the order function here. So we pass in the order function within our square brackets. And what are we going to order? We're going to order test scores, right? And what do I want to show in my order results set? I want to show all rows and columns. So I won't put anything after the comma here. And this will, in this case, we'll get an ascending order if I press enter. So ascending order from highest to lowest, right? From the bottom being the highest, the top being the lowest. We want descending order. So Celine got it. We're going to use the negative sign in front of test scores. Okay? And now we get it in descending order. Great. All right, so that was a little review. And if you have questions about this, let me know. But you should also make sure that you've gone through, lesson 2 in NYU classes. There's a video. There's a tutorial for you to follow along with, and some exercise to practice. And then you submit assignment 2 as evidence that you've kind of gone through everything. There's a question here that says it's not possible to use sort because it's a data frame, not a vector. Yes, correct. So we use sort for vectors. We use order for data frames. So this is why it's great to know our data types that we're working with, because then we can figure out which functions we should use. All right, so I'm going to bring up, I'm just going to bring up my PowerPoint right now. I have a few things I want to go over with regard to lesson 3. Okay. Bring that up for you. Okay, so here we are. So the remaining agenda for this session is to make sure that you're developing your knowledge and skills in R, right? So, and specifically from sessions 3 and 4, which speaks to R scripts and some other data structures, summary statistics, and give you an opportunity to practice. And so we'll practice together and also to answer your questions. So we'll begin by talking about the first topic, which is packages importing data and writing R scripts, which is pretty fun. So what's a package? Anybody know what a package is in R? So some people call a package, wrapped bundled pieces of software. Okay, Uli, that's a good start, right? It's like it's a collection of functions, right? That will act upon some R objects. It could be a set of data that we can access. So there are packages that are just packages of data. There are packages that are a set of functions, and typically in our version of R, we have some pre-installed packages, and then we have some that we need to install. So in RStudio, you'll see a tab called Packages, and you'll see all those packages that are installed, and those that have a check box mean that they're enabled. Okay, meaning that you could readily use them. What if you need to use a package that is not checked? Then you just basically use a function called library, and you say something like grid if you wanted to use the grid function. I just wrote it in the text chat, and that would actually check this box off. Okay. You can learn much more about all the packages you have installed by clicking on the hyperlink here. This is just a preview, like a screenshot of my page. We can also press the install button here to install packages. And for this course, you're going to certainly have to install more packages that then come with your default version of R, including one called ggplot2. ggplot2 it just says grammar of graphics, but it is basically a plotting packages that allow you to create beautiful charts and graphs and to access the various functions to do so. And a lot of times we need extra functions to help us do our work, to model our data, to analyze our data, to print it out, to read it in. And we always have to make sure that when we're using kind of more packages that are not installed with our default version of R, that we install them and enable them so we can use them. So I'm just going to escape out of here, and let's look together at a live version of our packages tab. These are all mine. If you want to see which libraries you have installed, you could also just type in a command prompt, library, open, close paren. That will bring up a list of all the libraries you have installed. If there's a library here that you're not using, that's okay. Typically, not all of these will be checked, which means that they're kind of like accessible and ready to use. If you wanted to check one of them, let's just say I want to check book down, it will literally just say library book down, and it gives the entire path for the location of it. If you wanted to enable book down yourself, you could just simply say library book down if you had it installed. And do you see how it checked that box automatically? Okay, for me? Wonderful. Now, if you want to install a package, you go to the install button here, and you're going to install from the default repository, and you type in the package name. So what if it was ggplot2? What if you needed that? So you type that in, you get that, select it, and then install it to your library location, which will be by default there. And it's good to install the dependencies and just say install. It will take less than a minute, and then it will appear in your list of packages. Any questions on that? Thanks, Eric. Good. So going back to the slide deck, just want to bring that up. Now let's talk about importing data. Well, what does importing data have to do with packages? Well, we're going to have to make sure we have a special package for importing our data. But there's a couple ways that we can import data. And what I mean by importing data is, instead of what we just did in our last exercise by actually building out our data sets, I'm sure you're not going to want to do that by hand. And so if I was in a class and I could see your faces, you probably would be laughing at least a little bit. No, we're not going to build our data sets from hand. We are going to import, CSV files or Excel files, and then manipulate those. And there's a few or two functions that we can use to read in our data. And there's some differences between the two. Does anybody know the differences, just offhand? Okay, well, these are two functions that come from two different packages. Okay, so let's go through the first one. Read.csv is a function that allows us to read a CSV file, which is a comma-separated values file, which is going to be the key way that we're going to be working with data. Where all of our files that I've asked you to download, have been CSV files. It tends to be more of a universal format than your XLSX Excel file format. Not everybody has Excel and the like, so we're going to use CSVs. And so this comes from a library called utils. The utils library is pre-installed with your version of R. You don't have to worry about referencing it. And if we look here, the read_CSV function, that's the only difference, comes from a different library called readr. You're going to have to install that one. So if you haven't already, what you do is go back to RStudio, go to install, and choose readr. Okay, and then you would install that. And then you would have access to the read_CSV function that allow you to read in data. If you've installed something called tidyverse, this package has libraries within it. So it's like a package that has multiple libraries or multiple packages, a package within a package. So readr is a package within a package, or also can be installed separately. Here we go. So back to this screen. The differences between the functions, like, why are we going over this? Why not just use one of these? Well, there's reasons. Read_CSV, the one that comes from the readr library, is a pretty new function, a new way to read in data in R. And so some of the documentation that you may see if you go to Stack Overflow and looking for solutions to problems, some people will still use the read.csv function. They haven't gone over to the kind of tidyverse style of things. So it's just for you to have a literacy around it. And there's some disadvantages of using the read.csv function. That's why there's a new one. First, anytime you use read.csv, your object or your data is going to be imported as a data frame. Well, data frames are good data structures, but we'll talk about some disadvantages of that. When we use the read_CSV function from the readr library, our R object is going to be imported as a tibble, which is a simple data frame. It's still a data frame, it's just a kind of a newer type, okay? It's like a data frame 2.0. And what this does automatically is remove characters as factors. So if I could jog your memory back to when we used the data.frame function, do you remember that? And we passed in students and test scores. And then we looked at the data type of that column called students, and we found out it was a type factor. That's why. Data frames by default convert all your characters to factors. It's a little annoying nuisance. And so we've all experienced that nuisance, even when we build data frames, not just import them. And so I just wanted to mention that to you. There's also some other advantages. When we have column names that are named with numbers, like 2007, the read.csv function will read in that data and automatically put an X in front of the name of that column. Versus what read underscore CSV will do, will actually put double quotes around the column name. So when you reference that variable. If I haven't persuaded you yet, we'll go through an example. So here's just an example of using the read.csv function. And we could specify some things like comma separated header equals true. You could also do that in the read underscore function. They're both the same in that regard. So if we were going to read in some data, we'd want to use the read underscore CSV function as a default. And we'll go ahead and try that. What I'd like you to do now is go to the Materials tab, click on Exercise 3.2, and we'll be working through this. So in Exercise 3.2, we're going to be working with this GDP data set. So pay close attention. What I'd like you to do is create a folder somewhere in on your desktop, call it like My Data or something, and store this gdp.csv file in there. All right, step one. And then we're going to go ahead and open RStudio up and do a few things. So once you've stored it there, let's go to RStudio. And I'm going to show you a couple ways that we can import data. One way is we can go to the Environments tab. Okay, I'm going to clear my global environment, so you can it just looks kind of blank here. And I could say import data set. And I have many options, right? Can you repeat where I get it from? Okay, so it's in Exercise 3.2, right? The Becoming Visual website. And there's a link here that says becomingvisual.com/rfundamental/gdp.csv. Awesome. Glad you got it, Jose. Going back to it's just kind of where we find all our data. I always kind of just give you the hard link to it. Okay, so we're going to import our data set. We have choices from Stata, from SAS, from SPSS, from Excel, text. These are the two I'm concerned about. So let's go ahead and say from text base as a first one. We import our data set, and we should navigate to wherever our GDP data set lives, that folder where you created it. I'm just going to open my folder up here. Say open. Okay, so we can see here that lots of different information here. So it gives us a name for our data set. Let's call this GDP underscore base. Okay, just to start. We have encoding automatic. You can pick the encoding if you have a different encoding for your files. And then the next option is heading yes or no. We're going to say yes. That means that the first row of data is the column names. If not, it's going to automatically assign V1, V2, V3. You see the preview below? We'll say heading equals yes. And then we know this is comma separated, so that's fine. And we see that strings as factors is checked as a default. Let's just keep the default because I want you to compare. Now look at when we bring in this data frame. Country.name will be the name of the first column. The second column, country.code. And do you see how there's X's in front of all these column names? So that's one way we can import our data. So I'm going to go ahead and say import. Now we have something in our environment called GDP. Sorry, can you repeat where you went to import? My connection was cut out. Jose, I just went to import data set right here in the environment tab. Import here. I navigated to wherever my GDP data set is stored. I asked you to store it kind of on your desktop somewhere. Looking for mine. So I'm just repeating the steps for everybody. GDP.csv, open. I'm going to call this GDP underscore base. And I'm going to say yes for heading because I'm going to use the first row. And I'm just showing you the preview of that because we're using, the clincher is we're using the read.csv function here, okay? We'll keep everything as it is, including strings as factors, and we say import. Now we have our data, and it gives us a preview of that, okay? And this one's called GDP base. Let's do it a second way, which is going to be, we'll say import data set. Not by default, Essie. Yep, and that's exactly what we learned, right? But we're kind of, I'm like proving it out to you. So then we say import data set, and we're going to say from text read R. Okay, so we're going to use the read R package to import this. We even get a preview here of what the code is, so we can actually type in the code at some point. But we're just using the interface now. We browse to our GDP data set. We're just going to re-import this wherever that's stored on your GDP. Okay, and then I'm going to open that up, and you get a data preview. Notice that there are no X's in front of our column names here. I'm going to call this GDP readr underscore readr, just so we have different names for our directory. And by default, we're going to keep everything first row as names, right? So first row, that means are the names of the column or our variables. No, Essie. If you chose readr instead of base, by default, strings would not be considered factors. You would have to convert them. Good. So then we just say import. So you could see how this previews differently. There's no X's in front of our years. And country name has a space between country and name, country code and the like, where it looks different here. So I just want to show you the differences between those. If, just a command line, if I wanted to reference the GDP base, right? This is using the read_.csv. This is the one that we imported just from the base package. And I wanted to reference a column name. I would have to say $, and the column name would be country name. This is how I reference the country name, right? So using country.name, that's the name of that column. How readr brings in that data is different. So we would say something different here. So we'll use GDP. This is using a different data frame. readr, $, double quotes, country name. Oh, okay. Eric, no problem. I use the up arrow at the command prompt. Up, 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 down, down, down. Good question. So I'm just showing you the differences in how these functions read in data. Any questions on this? Okay, now we're going to get into R scripts. And we're going to write an R script that reads in our data and does all this good stuff. So there are many advantages to writing your code in R as an R script. So we're going to transition from using R as kind of a calculator, which we've already done, and transition from using R as kind of a typewriter, right, where we're just typing in commands. We have to press the up arrow, right, to repeat a command, but there's no other really way to kind of see our logic of a series of steps, you know, from importing data to analyzing it, right? And that's what we want to get to. We want to be able to do that like in a single document, so we can save our work, we can reuse our code, we can document it, we can even kind of note to ourselves what we're doing and what a function does. We could share our work with others and move beyond writing one line of code at a time, right? So, at this point, you probably had just enough patience to kind of like be typing things at command line. But when you make a typo, you got to kind of type it out again or use the up arrow. So this time, we'll have our work saved. So we're going to go back to RStudio and create an R script. And you basically just go to the file window and you say new R script. And these files will be stored as .r files. Now, I want you to store those .r files in the same directory that you created for the gdp.csv file. Okay, so let's go ahead and do that. So I'm in R. I'm going to go to the File menu here, File, New File, R script. It's going to bring up a blank document. I want you to save this R script in the same place that your GDP dataset was saved in. So I'll say File, Save As. Okay. Then I have mine saved in a special place called R Fundamentals. And I have it in this document. And I'm going to name mine today's date. 04. It's today's date, the 9th, 09/2019. Okay? Go ahead and save that. Now, what I like you to do at this point is go ahead and go to the session menu, and I want you to set your working directory to the same directory where your R script is saved, even though there's nothing in it, and your GDP file. So then you go ahead and you choose your directory. I'll do the same thing. So I stored mine in something called R presentations. I select that and I say open. Now you'll see that down below in the console window, this is the command to set your working directory. Why is this important? Well, allows us to easily reference any files and data without having to write out the full path or location of that data, right? We could just give the relative path when we set our working directory. So writing an R script. So here we see this is the line number of our script. And I'll start by just kind of writing my name. Okay. Just like you would in a text file. Maybe I'll write today's date, which I learned is April 9th. And you'll see some stuff is color coded. And now I'm getting like some red X's. What's happening here? Well, what's happening is that this is not R code. This is just like text that I would just write if I was writing a Word document, right? And I want to say I'm kind of like working on exercise. We're working on exercise 3.2 here. These are all just like notes to myself. Any kind of notes to yourself, you're going to want to put a hashtag in front of them so they turn green. Okay? This means R will ignore this. It won't try to execute this or interpret it. So we're going to go ahead and anytime you see the R script's name in red with an asterisk, you're going to want to just save it. I just lost mine. Here we are. Save. Questions yet? So what we did is we created our first R script. We stored it in the same directory as our GDP data, and then we've set our working directory, okay, to that file directory on our desktop, let's say. Now we're going to go ahead and start writing some code. So we could, here use R as a calculator too. X plus 4, and then I can highlight line 5 and I can press the run function right here. It says X isn't found. Oh, I haven't defined X. Okay, so why don't we just define X? And then we can say X plus 4. Okay, highlight both lines of code, and then I can press this green arrow. Great, I can run. But what I want to I was trying to illustrate here is that this is anything you're running, and your output will be sent to the console window. Can you refer to your working directory you have set while writing a script? Sure. So in your script, you can actually, in the beginning, your first line of code could be, set working directory to wherever it is. Okay? And then I'll make a comment. Set my Is there a keyboard shortcut for run? Yeah, so you can highlight everything. So Command A and then Command return. Okay? Command A. I know, Eric, you can't see me do it, right? So it could just happen and you don't know where the mouse is going. Right. Yeah, and that's going to be really good. I'm gonna go line by line here, so I'm gonna get rid of this stuff. But we'll set our working directory. Wonderful. The next step I want to do is I'm going to bring up our questions that we want to. So just bear with me for 1 second. Our questions because we're doing exercise 3.2, so we'll begin working on that. And I just have to find this one here, so we can all look at the same information together. All right. Exercise 3.2, that's what we're working on, and we're creating our R script. And so the first thing we've done is we set our working directory. Great, because that's important to where our GDP data lives. And the second thing is that we want to import the GDP data set. So I'm going to write a comment that says import GDP data. And so how would I do that? Well, when in R script, I'm not going to go the slow way and kind of go to the environment tab and say import data set. I want to use the function to import it. So, and the function I want to use is, who can remind me to import the data? Close. It's read underscore CSV. That's the one we're going to use. Okay. And to use that, we need to make sure that we require the read R library. So we need to type in library first. We want to make sure that checkbox, because we know the read R library is kind of like separate. We need to install it. It's not by default enabled in our version of R. So we say library read R. And then we want to read in our data. So we'll call our data set GDP. And then we use read underscore CSV, and we can type in GDP.csv, and that should pretty much do it. Okay. Now, before we go any further, on part B, compute the difference in GDP we're going to run these 2 lines of code. So I'm going to go ahead and highlight these, pressing Shift and the down arrow, and I'm going to press Command and Return to run it. And we'll see in our console window that it looks like it worked. We can test that out by going to Environment tab, and we see now we have GDP data set, right? This is our data frame. And we can learn the data type of that. So let's see. So verify the data structure is a Tibble. And so we'll do that by using the class function. We'll pass in GDP. And I'll run this line of code. You can put your cursor at the end of the line, like on line 13, and you could press the arrow here to do that, or highlight and press Command Return. And we can see the class returned is a DBL underscore DF. That's kind of hard to interpret, but this means that it's a Tibble, and it's a data frame and a Tibble are the same thing, but this is a simplified version of a data frame. Yes, so Borgia, is the heading yes by default when you use read underscore CSV? It is. Mm-hmm. Can you refer to different libraries in the same R line? Or so we usually will just say library and then we'll just list them all separately. That's our convention. Great, thank you. So we're just going to use read CSV. We won't use read CSV2. There's different ones, of course. Many different functions. So we're going to stick with the one that produces the simple data frame, Tibble. It's going to give us everything we need. If we need to use the read underscore CSV2 one, there'll be a special purpose for that. But right now we don't have that special purpose. Let's go ahead and look at our next question, which says compute the difference in GDP between 2007 and 2017 for each country. So how would we approach this problem? Show the difference So I just wrote that in comments here. I'm saving my code. Celine, they're just a different set of functions that can act on the kind of like special type of Tibble data frame versus the regular Tibble data frame. So how would we approach this problem, showing the difference in GDP from 2017 to 2007, or vice versa, excuse me. We can do some subtraction, but Borgia, I'd say it looks like you're using your GDP days that you have the X's in front of the 2017, which makes me think that you imported, this is the .csv function that you imported, and you're working with a data frame, not a data frame Tibble. But that's exactly what we want to do. Okay, Jose, where do we find the recording of this session? Sure, so if you go to NYU classes, I'll just take a 2-second intermission to show you this, because I have it right. I'm pretty sure I have it up here. I'm logged out, of course, so let me show you real quick where you find it. It's under the recordings tab. So I'm in class recordings here, and then you see that these two are here. Okay, so our session 1, all of them are here, and I send them out in an email as well. After we do this one today, I'll send them all out. Okay, good. I'm glad I'm able to answer these questions so quickly. Keep asking them. All right. It doesn't bother me at all. It makes me think that like I'm helping you. So show the difference in GDP. So we had Borgia had like a great solution. Let's begin by just creating a column in our data frame, Tibble, GDP, that's called DIFF. And so that's pretty easy to do. So we just say GDP, and we're going to create a column. And so we use the brackets and the double quotes, and we'll call that column diff. That's the name of our column, okay, that we're creating. It's a new one. And we're going to assign everything to the value of NA, just for simplicity's sake. Let me click on that. And nothing happens, right? Because I'm working in an R script. I actually have to run this line of code. So once I do that, you can see in the output that no errors. If we go back to our GDP data frame, so go in the environment tab and you can take a quick look at it. You'll see a last column called diff with the values of NA assigned to it. Make sense? Yeah, Essie, so you're saying, I'm thinking about trying to solve the problem. First, we locate the country, then the GDP, then we do the calculation for all. And so the country, we know that every country in here is going to be like an observation, right? The country name. So we want to basically deal with every row. And we want to subtract one variable from the other. 2017 from 2007 for all the data. And we're going to want to store the result of that in this column called difference. Yeah, so we've done step one where we've created the column. And now what we want to do is be able to store that data, which is the result of our complex calculation, in this column. Okay, and so our calculation is pretty simple. GDP, $, what? We're going to pick 2017. So you'll see you'll get a list of variables here you can select from, which is pretty nice. I'll pick this one. See, I either can have, I could use ticks or back ticks or even double quotes. I preferred using double quotes just for simplicity, but you can also use back ticks. They both work. Okay. Minus, and then we'll say GDP, $, double quotes, 2007. Good so far? We press enter, nothing happens, right? Because we're in our R script, we actually have to run this code. So let's think about what we're doing. We're subtracting the value for all rows in GDP 2017 from GDP 2007. We're storing that in a column called difference. Okay, and go ahead and run that line of code. And then let's go ahead and look at our data. GDP. Oh, it's populated. And you'll notice when anytime there was an NA value, was resulted in the difference, right, from 2007, because it's not going to be able to do math on NAs. Is the column in, yes. So Christine, very good. So the column name is a number. And all numbers are, when they're column names, and when you use the read_CSV function, will have to be referenced using a backtick or double quotes. How do you view the data? Two ways. At the command line, you can say view with a capital V, and then you type the name of the data frame, GDP. That will launch this window. That's how you do it with code. You can also do it by going to the Environment tab and clicking on this little thing that looks like an Excel spreadsheet. And that will bring it up in the window too. Good? Where's the command that applies it to all countries? Sorry, I didn't understand that. No problem. Let's go back to our R script. So we're subtracting one column, all the values in one column, from all the values in a second column. And so it's all the values. It's not just one variable. All the values in this column. So thinking back to vectors, right? A vector can have one value or multiple values. Well, a column in a data frame can have one value or multiple values. We have like a couple hundred, I think, right? So subtracting, and we can figure out how many we have actually. If we did something like this, length, GDP, double quotes, $, double quotes, 2007, we can figure out the length of that column, 264. So we're subtracting 264 values from another 264 values and getting the result. Why is it that the double quotes are excluded from the diff columns in your last code? Oh, because diff is not a number. Anytime you have column names that are numbers, like the number 2007, when they're words, it's totally okay. And diff is the name of a column, but we don't need double quotes because it's just a column name. It's not and numbers are kind of special things in R, right? Because we can do math on them. And when we have column names that are named numbers, they require the double quotes or the backticks around them. Just some rules. Good questions. Good, good, good. All right, we have 11 minutes and we're doing well. So we've already done this nice subtraction. So now, right, so like instead of subtracting one number for another, we did 264 numbers from 264 numbers. Let's keep going. All right, now we're going to create a subset of countries that saw an increase of over $1 trillion. And these are some tips that are probably more relevant to the work that you just did before, but just as reminders. So how are we going to create a subset? Well, there's a couple ways that we can do this. So a subset, there's a function called subset. And so Anubhav has already shown us how to do this. So I'm going to call my subset countries. So I'm creating yet another data structure called countries. And I'm using a function called subset. And then I'm going to say GDP, which is the name of my data frame table that I want to subset. And then I'm going to say the long way, GDP $diff. I think I said greater than $1 trillion. And I want to return the countries. So we're almost there, greater than 1 trillion. So I think that's 12 zeros, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. Okay, we're almost there. Comma, we're going to use a statement called select equals the variable or the value or the column that we want returned, which in our case is country name. So let me just bring up the console window, clear that. So again, we're using the subset function. We're passing in, I haven't run it yet. We're passing in X, which is our data frame, our tibble, the condition by which we want a subset. We only want to see the result set where GDP, the difference column in the GDP data frame tibble is greater than 1 trillion. And what we want returned is country name. Okay. So one thing I want you to look at before we try just even running this code is question mark. Subset. Subset vectors, matrices, and data frames. And this is the usage. We pass in X, and then we have our different conditions. That's all I want you to kind of look at for now. We can go ahead and run this. And you can go ahead and in your environment tab, look at, oh, I didn't run it yet. Once you run it, you should have something called countries now. And you could see my countries here. I could save that. Any questions on this? If you wanted to do a single country essay, you would put an index there. So you would type in, so I'm just going to take Essie's code here and just type it in here. I hope I'm saying your name right. I'm sorry if I'm not. So this is code. If I want to do a subtraction of, say, the first one and the first one, right? The first value in here, okay? And I need to say $, right? Let's fix this up. And then I need my double quotes, right? So fixing up our code here. And then presumably this statement would subtract the first row of data, which from right, the first row of 2017 from that one. Which looks like NA. One of these values must have no values, right? Have an NA. Another question is, before creating a subset, what is the command to get a difference in value for Afghanistan? Well, you just subtract it, just like this. And so, I mean, you could say, you know, have some kind of condition, country name equals, you know, and then you kind of type in Afghanistan. You have to have some condition here if you wanted to do that. Minus, I mean, if you just wanted Afghanistan, you'd have to do the same thing. I'm not going to make this code work because I have to type all the other stuff out. But that's generally the pseudocode of how that would work. If you want to store that, you'd have to store that then, you know, in GDP $diff at the same location. You put in the same set of parameters, whatever location Afghanistan is in. So we won't do that. We'll just abstract each vector from each other. 2017 from 2007, store that in a new column called difference, and then take a subset based on that new column if values are greater than 1 trillion. Did I kind of answer everyone's question there? How would you view the GDP dollar amount along with the country? Well, with regard to dollar amount for what column? I think we can select country name / diff to do that. Yep, so you can add the diff column if you want, what you want to select to show. Great. So let's save that. We're going to go back to the presentation, and we have 3 minutes, but that's going to be plenty of time to introduce the preview of the 4th lesson out of 6 in the R portion of this course, which speaks to descriptive statistics. I'm getting a great question here. Natalia saying, why do the values look funky? Such as, like, we're using scientific notation, right? Everybody sees what Natalia wrote in the text chat. It depends where you're seeing that. If you're seeing that in the output of the console, we can format our data so it doesn't show up that way. You're seeing it in the preview when you're looking at, when you're using the view function and seeing kind of like a spreadsheet view, that's totally okay. But we can also change that as well. You change that by having a line of code. I'll just type it out and you can type it yourself. Options equals, it's called SciPen equals 999. And this will get rid of all scientific notation in your output for your session. Okay, you could just type that at the beginning of your script as you. Yep. So descriptive statistics in 2 minutes. Well, you're going to have a whole half of a course on all this good on using various statistical models. But since we're already starting to work with data and larger data sets, it's important that you can begin analyzing them. And we tend to do that by computing some measures of central tendency, including, you know, variability, correlation. We might want to know the average or the middle of your data. And so there's functions that allow us to do this. So we can use a function called mean or median, or table or max or mean or range, and a lot of these. And so in the next set of exercises, which I'll just bring up here in 4.2, we're going to use the GDP data set, and I want you to find the mean, the median, the range, and the quantile. And I have a little like caveat for you. It says you could actually go ahead and divide the 2017 column by a trillion, so you're not working with such big numbers. And you could use the NA.RM equals true when computing the different measures. So I'll just do one quick demo, and then I'm going to let you go because it's we're at time. But let's say that we're going to start here, and we're going to say compute the mean. And if I want to compute the mean for the GDP 2017 column, this column, I'm just going to copy it. So we have this. We can use a function called mean. We pass in the column that we want to compute the mean for. Let me show you what happens first. Here, I'm on line 20. I get an NA. Why do I get an NA? Because there are values in here that are NA values, so it's not going to do this computation. So we need to add a special parameter called NA.RM equals true. Remove any NA values and then compute the mean. Not remove them from the data frame, just remove them from the vector of numbers that you're computing. And then we press enter. And we should get this in nice scientific notation. If I did that, options SciPen equals 999. First, and then this, I should mine's not working right now. I think because I have a different configuration. But for you, that should work, and you'll get the mean, okay, here. Before I asked you to kind of take that GDP column, right, and then divide by, you know, I think I said divide by a trillion. Okay, so if you divide by 12 zeros, and then assign that back to itself first, and then you take the mean, you'll get a different result. We did that, and now I'm getting 2.84. Also get sort of that messy scientific notation. Okay, so this will be recorded. You can take a look at it. Thank you for your participation today. Finish up with exercise 4.2. There's only a few more problems to do there. And I really appreciate your participation. Let me know if you have questions. The PowerPoints I'll send around today. It's really just these, which, you know, I just had a few slides today, but certainly I will share those as well. So thank you for asking, Christine, and you'll definitely get those. Any other questions? I'm going to turn off the recording and stop sharing my screen.